Permanent packer, full system overview. Explanation. This illustration highlights the anatomy of a permanent production packer. It shows the mandrel running inside the casing, slips anchored to the casing wall, and the seal elements engaging the tubing or casing bore. The illustration emphasizes that the packer is a primary barrier that isolates the annulus between tubing and casing. Metal-to-metal and elastomeric seals are clearly indicated, demonstrating how they prevent fluid communication from the reservoir to surface. This visual reinforces the understanding that failure in any component, slips, seals, or mandrel, compromises barrier integrity. Hydraulic set permanent packer, setting sequence. This step-by-step illustration explains how hydraulic set permanent packers operate. Applied tubing pressure drives a piston, which expands the slips into the casing and compresses the seal elements. The arrows and color coding demonstrate force and motion direction. The visual clarifies that hydraulic set packers are ideal for deviated and horizontal wells because the setting force is independent of pipe movement. It also emphasizes the criticality of proper pressure application and monitoring during deployment. Wireline-set permanent packer in slimhole. This illustration shows a permanent packer being set via wireline in a slimhole completion. The E-line, firing head, and setting tool are labeled. It highlights that the packer can be deployed without requiring tubing movement, making it suitable for live wells or narrow annulus conditions. The locked-in position shows how the packer becomes a permanent barrier, emphasizing that once set, it cannot be retrieved without milling or cutting. Mechanical set permanent packer, rotation/tension setting. This illustration demonstrates mechanical set packers that use rotation or tension to engage slips and energize seals. The sequence shows torque being applied, slips expanding, and seals compressing. The technical detail explains that this method is still used in specific completions, especially vertical wells. It reinforces the understanding that improper torque, casing scale, or misalignment can prevent the packer from fully setting, which compromises the primary barrier. Explosive set permanent packer, obsolete technology. This diagram explains the concept of explosive set permanent packers safely and educationally. A small pyrotechnic charge triggers rapid expansion of slips and compression of seal elements. The illustration emphasizes that although this method is mostly obsolete due to HSE concerns, it historically allowed quick deployment in specific applications. Color coding shows the activation signal and final lock position, demonstrating how the barrier becomes permanent. Permanent packer failure modes, high-risk conditions. This technical infographic shows the four main failure modes: seal extrusion, slip failure, pressure reversals, and debris interference. Red zones highlight areas where failure occurs, while debris or scale is represented visually. The explanation clarifies how each failure compromises the primary barrier, emphasizing the importance of inspection, pressure monitoring, and cleaning before setting. This illustration educates operators on the risks of high temperature, high pressure, or poorly maintained casings. Permanent packer application environments. This illustration demonstrates where permanent packers are typically used. For sections show HPHT gas wells, geothermal wells, SAGD injection/production wells, and deep gas reservoirs. Each environment includes temperature, pressure gradients, and wellbore configurations. The explanation reinforces why permanent packers are selected: high-pressure reliability, long-term isolation, and suitability for extreme temperature or corrosive environments.